Our next speaker is Andrew Radev. He's been working with Rails for a while, and he's been in the back end, at the front end, and most of the places in between. He's also a Vim wizard, and he's a maintainer of Vim Ruby and Vim Rails. Also, he's quite humble about it. So I give you Andrew and his rules, laws, and gentle guidelines.
Right. Hello. Hello, everybody. Can you hear me? Is everything okay? Okay, cool. So hi, my name is Andrew. You can find me on the internet as Andrew Radev. And if you're having trouble with the last name, just remember it starts with Rad and it ends with Dev. And it's basically what I am. Today I'm going to talk to you about rules, laws, and gentle guidelines. And the law part of this comes from the Law of Demeter, which sort of inspired this talk to begin with. Now, if you don't know what the Law of Demeter is, it basically goes, if you have this sort of line of Ruby code, you see all the dots over there, that's bad. You shouldn't have that many dots. What you should do is you should replace them with underscores, and you end up with a great method name called user profile address. And stuff like user first name, order item, and of course my favorite, created at toDate. All methods that I've actually seen in the wild, by the way. So, okay, this isn't exactly what the Law of Demeter is about. I'm going to go back to the source and tell you it was originally defined in a paper called Object-Oriented Programming, an Objective Sense of Style. I'll talk a bit more about the objective bit a bit later, but it was 1988, and a definition, the formal definition, which I actually kind of stole from Wikipedia because I like that one better, goes like this. If you have a method M defined on an object O, in the actual method definition, you're only allowed to call methods on the following kinds of objects. On O itself, so other methods of the same object, makes sense. On M's parameters, right? This is interesting, and we'll talk about this a bit later. Any objects that M instantiates, any direct component objects of the object, so instance attributes and such. And global variable, well, that has its own problems, so let's not talk about that one. In other words, you can pick your friends and you can pick your nose, but you can't pick your friend's nose. Unless they've been provided to you in a method argument. That works. The best interpretation, the best explanation of the Law of Demeter that I've ever seen comes from an article by David Bach called The Paperboy, the Wallet, and the Law of Demeter. And in it, the scenario is a paperboy delivers a paper to a certain customer, and the paperboy demands payment. Now, in order to pay the paperboy, the customer, we get the wallet from the customer, but we get wallet, and then we call subtract money on that wallet object, which, seems pretty reasonable. The problem with this is that the interpretation is basically, well, you're giving your wallet to somebody and going, take what you need and leave me the rest, which is not ideal in practice. Even if we don't talk about the real-world interpretation of this, it's still not ideal code because the paperboy is being exposed to more information than it needs to be. The paperboy seems to know all about the wallet, all about whether there is a wallet or whatever the wallet is nil. And we'd like to decouple that code from the concept of a wallet altogether. We don't care if the payment is done with a wallet or with a credit card, Bitcoin. I mean, for a paper, maybe not appropriate. But anyway, the point is, David Bach suggests a method called getPayment, which encapsulates the payment logic, whatever it happens to be. And in this case, the code might look something like this. Now, you might notice that the method is called getPayment and not getWallet subtract amount. Right? We don't just concatenate the two methods together, right? Even if we call it something a bit more sensible, like subtract amount from wallet, even that it's not an ideal method name because it still mentions the wallet. There's still some implicit coupling. We don't have a wallet object now. We don't care about the API that much, but we still mention the wallet, so that, which means we can't really switch implementations that easily. And this is mentioned in the actual original paper. There's a slightly different example, but it is similar. Section 7, the interface, if you're following along at home, it goes, the above method appears to obey the Law of Demeter, but on closer inspection, it clearly violates the spirit of the law, So it's not really about replacing dots with underscores. In this case, if we have a more Ruby-ish example, replacing user.address with user underscore address, Right, user address is not a terrible name, is it? It's an okay name, but it does couple this method's implementation to the user. What if there is no user in the shopping cart? You know, this is very easy to do. It's extremely easy to do this in a certain framework that everybody might like. It's easy to just say, you know, delegate address to user, and you end up with a user address. But you know, a better name might be shipping address or billing address or any other method name that makes sense in the context of a cart. That way, we can easily replace this with, well, with a proper relationship that has nothing to do with the user, or we could even use some sort of a card that doesn't even have a user, an anonymous card that figures out the, you know, the address based on GOAP and the actual products that are included in there. Like, you know, if the shopping cart includes, I don't know, soy milk flavored like currywurst, that's, you know, it's probably going to Berlin. So point one that I want to make about the Law of Demeter is that naming matters, that you can't just delegate stuff and call it a day, because you still end up having implicit coupling between the methods. Point two is that you don't even have to delegate anything at all. In some cases, you could you know, resolve the problem that the Law of Demeter is pointing to by extracting a method parameter. For instance, let's take a look at a user that has like a dozen email-related attributes, right? And we might have a method that, you know, asks the user, should we send a weekly email to that user? Now, we might want to extract all of these email attributes to a separate object called email settings, let's say. The problem now is that we have a Law of Demeter violation because we call user email settings weekly summary, right? Now, one way to fix it is to delegate, but it seems like we'd be taking a bit of a step backwards. What we could do instead is we could inject the email settings as an argument. We would call weekly summary on email settings and daily summary. We would use the user just to provide it to the actual email sending methods. In fact, we don't even need to call it a user now because the API of the user is no longer relevant. We can call it a recipient. It doesn't have to be a user. It doesn't have to be connected to a set of email settings. By doing this, you know, most of the code that we currently have is probably going to be, you know, just going to look like user, first argument, user, second argument, that user's email settings. But in the future, we could easily give a user the first argument and give a different set of email settings for that user, maybe from the organization they're in or whatever. So we've decoupled this code. You know, this code doesn't need to know about the connection between the user and the email settings, if a connection even exists. Now, I say that, and it is you know, more decoupled code is great, it's amazing, but to be completely honest, if I were to refactor this, if I were to pull out an email settings object and so on and so forth, I would likely just do something like this. I would likely pull out the email settings at the beginning of the method and then, you know, use them and the bottom half of the method does use email settings as a proper domain object, which is useful. You know, it establishes that, yes, this is a useful domain object, but it is a Law of Demeter violation. You know, we do have the coupling between a user and the email settings. But we also have gained, the thing that we gain here is that we don't have to change the signature of the method. And this, it might be, you might say, well, sure, it's not a big deal, right? We can grep around and we can change it, but we might also have another 10 to 20 methods that we need to do the same thing in. And it might be not a good idea to do this early on, but maybe we can do this whenever we do have an organization, whenever we do need this method to be decoupled. Now, you might disagree with me on this. You might say, well, yes, but it's better to establish a precedent. It's better to decouple this code early on, which is great, because in that case, you're not telling me we should do this because of the Law of Demeter, but you're actually making an argument here. And that's my third point, that it's not an actual law. It's, you're not going to go to jail if you break it. You're also not going to get a Nobel Prize. It's also not that kind of a law. It is, it's as much as a law as the paper describes an objective sense of style, especially considering that the actual paper says something like, well, in order to prove it, we would need a pretty large-scale experiment, so we don't have that, but we do have 14,000 lines of Lisp code, and it seems to work for that, so it's objectively good. And the funny thing is, the actual paper is, well, it is very nuanced. I mean, it does have a section called trade-offs, which goes like, writing programs with the Law of Demeter increases the number of methods, the abstraction may end up being less comprehensible, implementation and maintenance are more difficult, there might be an increase in the number of arguments passed to some methods, which kind of reads like on a medicine bottle, sort of the side effects, like expected side effects right here. And it is true, if you've been paying attention to the examples, you can see how taking it to the extreme might end up with, we might end up with a lot of methods on a particular object. We might end up with a lot of arguments objects. It kind of depends. So there's a trade-off here, which is why I really don't want to call it the law of Demeter. I kind of dislike the name. I really would prefer to call it the guideline of Demeter or something like that. It's a tool to understand your code. It's a tool to figure out where there's coupling in the code, and at that point you can decide on your own or with your team, how exactly to fix this problem, or whether to fix it now or delay the solution until a later time. And it's definitely not a weapon to win internet arguments, which I've seen it used more often than I'd like. Much like a different principle called SRP. I think it's a very popular principle, at least, a single responsibility principle. And it's kind of obvious in terms of, I don't know, like the name really says it, right? Single responsibility, classes should have just one responsibility, methods should have just one responsibility, do one thing, right? Like say, this class, which, obviously updates the comment. It's right there in the name, isn't it? And it's initialized with a comment. We save the comment in a transaction, and we do two other things that are somehow related to saving the comment, to updating comment, just some sort of dependencies of the comment that we encapsulate in this nifty method called update, in this class called update comment, which is, it's okay. It's not a bad class. It's reasonable, does one thing, until you see another class called destroy comment, which, well, it destroys a comment and then it calls the exact same methods. And all right, so these two methods are literally copy-pasted between these two classes. So I'm not saying that both of them are not single responsibility. They are, but maybe there's a responsibility they're sharing there that kind of is not in the right place. We could use callbacks with our ORM. We could do that. Yeah, that's not SRP though. I mean, it's not SRP. This ORM is not SRP at all. It does so much stuff. It's not okay. All right. What about we still need to merge these classes somehow, right? We still need to use like just one class for it. What if you call it the comment manager? Yeah, that's not SRP at all. Haven't you read that blog post that said managers? You can't call things manager. That's bad. All right. How about we call it the comment lifecycle? We give it a comment. We have an update method, which does the whole update dance. We have a destroy method, which does the whole destroy dance. Comment lifecycle has the responsibility of taking care of any sort of changes to the comment's lifetime. We could add, I don't know, like we could add states there, publishing, unpublishing, moderation, who knows? Yeah, I don't know though. It's like there's two methods in there. There's two methods in the class. It's not very SRP. Not very SRP at all. All right, so let's take a step back and talk about the origins of SRP. It was invented by it was named by Robert C. Martin, and he sort of created it as a natural extension to the concepts of separation of concerns, coupling, cohesion in the 1990s. I couldn't find the definitive definition, but in one of his blog posts, he does explain it as each software module should have one and only one reason to change. Now, this is interesting because the way I've heard it and the way I've experienced it and the way I've argued with people, or people have argued with me, it's more of a, you should do one thing, right? You look at the class, you look at the method, you go, whoa, this should do one thing, or it does too much. It does too much. We should split it up or something. But instead, Uncle Bob names it, calls it should have one reason to change, which is a bit different. I would argue that they're actually quite similar and they're sort of different angles to look at the problem, but it is a different angle. And I don't really hear that much in arguments, to be honest. I haven't really had anybody go like, well, this class has two reasons to change. And more often than not, it does too much, right? So I'm now faced with the problem that I'm not sure which one of the two things to complain about. So I'll just complain about both. Let's start with an example. We have a test here that has like goes to the registration page, fills in login details. I really should have like actually showed you the page, as in actually designed it, but it was a lot of effort, so I didn't do it. You're gonna have to use your imagination. Fill in login details. He goes like, well, you fill in the email with the parameters, like you can imagine like this little box with email and password, right? And fill an address does basically the same thing with like more inputs to the box. Hope you can see it in your mind's eye. And fill in banking info fills in the banking info and also clicks the submit button. And I don't know about you, but this bothers me so much. Because it doesn't do, it does too much. It definitely does. I think I would be safe to say that this method does too much. A pretty easy thing to do here is to just separate it into two pieces, right? Fill in banking info, what does it do? Well, it fills in these fields, right? The banking information. Submit form, what does it do? It clicks the right button. Code looks like this, perfectly reasonable, makes sense. All right. But what if we did something different? What if instead of taking stuff out, we put some more stuff in? What if you put all of the email fields and the password fields like right there in this method that's called fill in banking info? What if we also put the first line, it goes to the register page? Now, the fill in banking info does everything. Well, that's terrible, isn't it? It's way too much, right? I mean, I took a method that already did too much, and I made it do even more stuff. Well, what if we named it register user then? We name it register user, and it goes, well, what does it do? It goes to the registration page, fills in all of the fields in the user registration form, and then it submits the form. Code looks like, register user, expect whatever. Register user, again, expect that an email has been sent, maybe register it with invalid user parameters. We can reuse this method all over the place, and it seems like it makes sense. It seems like it does one thing, doesn't it? It registers a user. The thing is, the way I like to look at it is the problem with looking at a method and going, well, it does too much. The reason that it does too much might be related to the fact that the name of the method doesn't accurately fit the contents of the method. It's kind of obvious when I say it like this, but it is a different angle to look at it. So there might be a name that we can use that would change this method to not really do that much. There would actually be a name that would fit the current contents of the method, which would work. So again, we kind of have a naming problem here. As in, first of all, it's a good idea to think about, is this the right name for this abstraction? Is this why maybe we're feeling that that this method or class or whatever does too much? Maybe there's a concept here that we're missing, right? And it also shows my second point, that it's not always about splitting things up. I don't know about you, but I've often had this problem with SRP is that a lot of people, they use SRP as sort of a reason to chop up the code into little pieces. And you could do that, right? But as you can see, you can also sort of redraw the borders in a different way. You can add more stuff to it, right? You can add more stuff to this method and rename it in a different way. You can move things around, and it still works in some way. And I showed you this example in the beginning, but I didn't really explain why this example is separated this way. Why do we have 4 methods here? There might be a reason, right? There might be that, we use these address and banking infos in other places, right? We have other places that we fill in the stuff. But it might not be the case. In fact, if it isn't the case, by separating them into 4 different pieces, we end up just copy-pasting this block of 4 pieces every time we need to register a user, right? We could still extract it in a method, but there's a question of, do we need these 4 methods? And I don't know if we do. It kind of depends on the context, and, well, I made up this example, so I didn't really make up the context. Who knows? But it is very easy. It is actually much easier to look at this method and go, well, here's an easy way to fix the issue. Just split it up at that point. It's very obvious, and you don't really need to look at anything else. You can just look at this one method and limit yourself to it and go, if I split it, it'll work. But you might also take a step back and see if there's a different way to achieve a similar thing. Not by splitting this method, but by reordering the code in different places, redrawing the borders. So how do reasons to change fit in the whole thing? Well, in Principles, Patterns, and Practices, Uncle Bob, Robert C. Martin, described this example of an interface, a modem interface, with 4 methods: dial, hang up, send, and receive. And he points out that the dial and hang up methods have to do with the connection, and the send and receive have responsibility over the actual message passing, right? And he says, these are 2 responsibilities, and they are. You could name them in this way. Should you? Well, it depends on how the application is changing. If the application is not changing in ways that cause the 2 responsibilities to change in different times, then there's no need to separate them. if they were changing, separately, independently from each other, maybe they were even handled by different teams. I mean, in this kind of example, it's a bit difficult to have this idea, but think about separating HTML and JavaScript, for example, or HTML and the database layer. If you happen to be a web developer, all my examples are webby. I'm sorry about that. Anyway, what he says is that an axis of change is only an axis of change if the changes actually occur. It's not wise to apply the SR principle, or any other principle for that matter, if there is no symptom. That's what Robert C. Martin said, the actual, the person that introduced SRP. And this is my my last point, is that reasons to change is a bit of an estimation. You can't really tell what the reasons to change are definitely going to be. You can make an estimation based on your experience, general experience, your experience with the project, your experience with this particular team, your experience with the business even, as to how things will change in the future. And it's very likely that you might be wrong. But again, this is, it's just a tool to understand your code. It's just a tool to look at the code from a particular perspective and go, well, it seems to me like this is the way it might change. And it's not really appropriate to just go, well, this isn't SRP, let's cross it out and let's do something else. You might want to explain why you think this is the case, because it's a bit of a fuzzy principle. A lot of these principles are kind of fuzzy, to be honest. Like, I wish I had the time to, to go over all of them and explain why I think they're very fuzzy, but I don't have the time. I really wish I did. I don't really wish I did, because it would be a lot of effort, but, I wish I did have the time, and also infinite willpower. That would be great. But I don't have time for that, so I'm going to talk about one last principle, which is very close to my heart, not in a good way. It's easier to ask forgiveness than it is to get permission. Not exactly a programming principle, but often used in this context, I've discovered. And I have a story about this one. I actually have a lot of stories about this one that all start in the same way, with me coming into the office, in a generally good mood, getting a cup of coffee, being very happy and joyful, and then pulling from Git. And in this particular story, when I pulled from Git, I discovered that somebody has been hard at work at 3 a.m. in the morning. You see, there was this one partial, just an HTML fragment that is being reused across the application, something like that, right? Some product or whatever. And it was gone. It wasn't there anymore. I was wondering why that might be the case. Where is it, right? Started to look for it. The place where it's actually rendered, well, it isn't rendered in the standard Rails way anymore. It's rendered with some method called on some class. I'm starting to get a bit more worried, because I'm looking around for this class and grabbing around for this class in the application. I can't really find it. Can't really find the class anywhere. Where is the class? Why can I not find how this partial is output? And then I discover that there's a new gem in the gem file. Some internal gem, which at that point I'm getting really, really worried, because why would this one sort of HTML fragment be taken out of the application? Like, I don't know how many of you are web developers, but it's the CSS for this partial is in the application. Like, all the JavaScript that has to do with it. Like, if you ever have to change anything, like styling or whatever on it, you have to know that it's in a separate library, and the library name doesn't really make much sense in connection to this particular partial. And I'm very confused, starting to panic, starting to have a really bad day now. But then I look at the actual gem, and I'm enlightened. You see, the gem had a C extension, and the C extension had a macro, which was anyway, a lot of web developers in the team had noticed this. And we sort of got together, and we couldn't talk to the actual person. You see, the actual person wasn't exactly in the development team. He was kind of an administrator, but not exactly. He was sort of a genius. I don't know if you know the kind, the one that commits stuff at 3 a.m. in the morning, 3 in the morning. We talked to the CTO, who was fully on board. He was, this is great. It's very fast. It's very fast, which is, no, listen, to be fair, it was very fast. It was very fast. It was, in fact, almost as fast as it used to be when we were caching it with memcache. But we wouldn't need to cache a memcache if it was just coded properly. It wouldn't be necessary to cache it. It would be working, coded properly in C. A phrase that he used was use the best tool for the job, which is another principle that I could talk for another 10 to 15 minutes for. But this example is going to have to suffice to show my opinion of it. We're not really going to touch it again. It's just there, it's fine, it's working, it's okay, it's not really going to... this was empirically disproven, by the way, because in the next 3 months we had to implement some minor stuff like translations and date formatting and parsing with localization and time zones, and HTML escaping. Turns out that the printf family of functions does not automatically HTML escape its inputs. There's not even a flag for it. One might argue that maybe it isn't the best tool for the job then. But we did touch it again, we did. But this last point, this last point that he made, this is the reason I'm putting it in this bucket here and telling the story. It's already done. It's done, it's right there. And what are we gonna do, revert it? His hard work that he put in at 3 in the morning without consulting anyone? This is why I hate this principle, to be honest, because it is absolutely true. It's easier to ask for, well, the forgiveness part, to be honest, is kind of optional. I've noticed, anyway. I can't really remember a situation in which the forgiveness part ever sort of occurred. But it is easier. It's so much easier to just, you just don't care about what anybody else is going to say about it. You just do what you want. And then they'll probably thank you in the morning. I'm sure that they'll go, oh, I'm so glad that this was implemented. But I know what you're going to say, right? This is a stupid example. It's an extreme example, right? You wouldn't do something like this, right? You would never do something like this. Like, if you were to do something like this, it would be correct. Like, it would not be stupid. Which may be the case. It might be that, you know that everybody else is, I'm not going to say stupid, but maybe too set in their ways to appreciate whatever it is you're trying to do for them. But even if that's the case, even if you are categorically correct, like even if I went around all my coworkers' workstations and I replaced their Sublime text with Vim. Now, I'm not saying that Vim is better than Sublime text or anything, although it is true. But what I'm saying is, it's even if it were true, right? Even if it were 100% objectively true, which it is, I kind of feel like, if I talk to the CTO and got him on board, like, oh, we have Vim now everywhere, it's the newest shit. I kind of doubt that people would just go, oh, well, I guess I have to learn to like Vim now, 2 days before my deadline. I guess that's just what I'll have to do. I'm very glad that somebody did this without talking to me and trusting my judgment in any way. I don't know, there's a lot of context involved in the whole thing, right? I mean, maybe there is a context in which this does make sense. Maybe there's a context in which you could just go, there's servers on fire, you know what to do, you're not gonna go around and ask people what to do, right? You're not gonna consult with people, right? But it kind of, you kind of have to think about that context. You have to learn to apply this context. And you can't really fit a complex context-dependent programming principle in a tweet-length sentence. Although, funnily enough, this one fits quite nicely in 140 characters. When I first learned about pretty much all these principles, like the Law of Demeter, it was eye-opening. It was like, oh, like this is why I'm in such spaghetti. This is why I'm writing all these chains of methods, and not so tightly coupled. Well, I didn't call it coupled at that point, I suppose. But every new principle would give me this additional understanding of how to write better code, in what way my code fails badly. But in time, I would also come to learn the drawbacks, what happens when you take it too far, what happens when you go overboard with trying to, with creating like 30 delegations that delegate to another 30 delegations, which delegate to, and you end up in a place where you could just call any method and it would call anything and something at some point. It's about figuring out, with time, okay, when I was preparing for this talk, I even, I read the actual paper, like the original paper, objective sensor style, and most of the stuff I read there, I already knew. Like blog posts, videos, you find this stuff out. Yeah. Some of this stuff you even find out by yourself. But I did discover actually something brand new. I did discover that there's a strong law of Demeter and a weak law of Demeter. I didn't know about that. I don't know if any of you know about that. But I do think that it was actually something brand new I learned for a principle that I've known for years. And knowing all this stuff, trying to learn this stuff, trying to push yourself to learn this stuff, ends up to being able to apply it better. Ends up to being able to figure out, what is the good way to apply it? When should I not apply it? When should I just know, hey, this is, it's good and all, but at this point in time, it's not a good idea to go in that direction, maybe. And the last advice I can give you is don't force push stuff to master at 3 in the morning. I will write a white paper if I have to. Please don't do it. Thank you for your time.
Thank you, Andrew. I really love these worst time stories. Like everyone has of them. If you have any questions for Andrew, find him in the hallway and talk with him.
I have a lot more stories.
Yeah.
A lot.